Hello everyone, my name is Anthony Womack, and this is my final presentation covering direct air capture, or DAC for short. In the presentation, we are going to be walking through what exactly DAC is, how it works, and its potential as a climate change solution. We'll also cover some of the real-world projects that are currently working on, the current technical and environmental impacts that are also currently going on, economic factors, and the broader social and political context on DAC as a whole. So, let's get right into it. Direct air capture, or DAC, is a climate engineering technology designed to pull carbon dioxide directly from the air. It involves large machines that use fans to move air through chemical filters that trap the CO2. Once it's captured, the carbon can be used in numerous industrial processes or just stored underground for future use. As a carbon dioxide removal strategy, DAC aims to reduce the concentration of greenhouse gases in the atmosphere, helping to mitigate the current climate change situation. One of the leading companies at the moment in this space is Climeworks. They are based in Switzerland. In 2021, they launched Orca in Iceland, which is currently the world's largest direct air capture facility. Orca uses renewable geothermal energy to power its operations, helping to minimize its environmental footprint as a whole. The captured CO2 is stored then underground in basalt formations, which it mineralizes over time, locking it away permanently. DAC is meant to lower global CO2 levels, which is crucial in the fight against climate change. However, of course, with any sort of climate change fighting method, there are significant trade-offs. These facilities require a lot of energy to work, and if they're not powered by renewables, they can often produce more emissions than what they are taking out of the air. There are also concerns of land usage and water consumption as well for cooling and just building these ginormous facilities. And while Orca is powered cleanly, scaling this technology globally could put a lot of stress on natural resources if it's not managed carefully. So while technically DAC is possible on a large scale, it's way too expensive to be able to actually be produced at any sort of larger scale. Current plants like Orca, like I mentioned before, remove thousands of tons of CO2 from the air per year, and while global emissions are still in the billions. Scaling up will require new infrastructure, innovation in materials, and greater energy efficiency that we currently do not have. Without those improvements, DAC will remain more of just a pilot in a global solution to the current climate. Now, the biggest hurdle for DAC, or for the people that want to implement DAC on a global level, is the overall cost. It currently costs between $600 to $1,000 to remove just 1 ton of CO2 from the air. But like most tech, prices could fall as technology improves and scales up. There's also the potential for job creation and growth in the carbon removal markets, especially as policies and industries start valuing carbon reductions financially. Now, the best thing about DAC is that the public awareness around it is growing very rapidly, and many people are hopeful about its potential as a whole. But of course, there are ethical questions. Some worry DAC gives industries an excuse to keep polluting rather than cutting emissions, since they can just go and build a whole factory elsewhere to just, break off their stuff. For it to succeed on such a large scale, international rules and cooperation will be essential, especially since the atmosphere is a global resource. Like any carbon storage method, DAC carries risks. We have to be sure that once CO2 is stored, it stays stored, and that's where monitoring becomes essential. According to the International Energy Agency, carbon capture projects must include continuous monitoring systems to ensure CO2 levels stay locked away and leakage risks are minimized. Another concern is that society might rely too heavily on DAC instead of cutting emissions directly. That's why flexible policy, transparency, and oversight are essential as this technology develops further. So, just to summarize everything in conclusion, direct air capture shows real promise, but it's not a complete solution on its own. It's expensive, limited in scale, and it carries significant risks if it's not managed well. But when paired with emission cuts, transparency, and innovation, DAC can play a valuable role in helping fight climate change as a whole. The key is just making sure we use it responsibly and not as a shortcut. All right. Thank you guys for listening.